This presentation is related to bridges and will help you to understand the bridge project and give you all the basis for the bridge project that you will be doing these weeks. Those are the main contents that we'll be studying. And the first of them is history of bridge development. Bridges start with natural bridges like a tree trunk or stone that people were using in order to pass from one side to another side of the of a river. This is, for example, an example of a clapper bridge that is made out of stone and allow the people to pass from one side to the other side of the river. After in the 700 AD in Asia, low bridges were made and shallow arches were created. A famous one is the Great Stone Bridge in China, the Changshu Bridge, that has like an arch. After, during the 1000, Romans started working with 100 BC, sorry, Romans started working with arch and natural cement, and they create the Roman arch bridges that were very strong and very good from the structural point of view. In the 1300, during the Renaissance, strength of materials, mathematical theories, and development of metal were created. Therefore, in the year 1800 AD approx, other type of bridges that to appear, and the first cast iron bridge is the Holbrook Dale, located in England. That is a wonderful example of a bridge made with cast iron for the first time. In 1900, truss bridges were developed because we start studying what is the mechanics of design. Before that, tubular bridges were made in wrought iron, and suspension bridges were made using steel for suspending cables. And finally, in the 2000 and later, became more logical to build bridges of pre-stressed concrete and steel and cable stay bridges. How a bridge will work? Well, a bridge is not an element that is a lifeless mass. It's an element that moves, and we need to understand the moving of this element. Obviously, when we have vehicles, for example, that are passing through a bridge, they will cause wave and movements, and the speed that are hundreds of kilometers per hour will really affect the bridge. But by fortune, the bridges are designed to dampen them out, and this movement will be ignored, as well as the wind attempt to move the bridge. Well, there are some basic concepts that you already understand. The span of the bridge is the distance between the two supports. The force is any action that will tend to maintain or alter the position of the structure. Compression is a force that will make the material smaller, and tension will expand the material. Also, we have a beam, obviously, that you know that is an usual horizontal structural elements that will be transmitting the forces to the piers, that are like the supporting elements. A cantilever is when the structure is projected, as you can look here, and only supported in one end, and the load are the weight distribution through that structure. Also, among the bridges, we have a type of bridge that is truss bridges, and the truss is a rigid frame that we will study later on, that is composed of short strain pieces joined to form like triangles, or any other shape that is stable like triangles. Stable is the ability to resist any deformation, and that will allow the material to support the loads and eliminate the possibility that that will deform too much. There is always a deformation, but the deformation cannot be strong because people will not be able to use the bridge. And the deformation is the change of shape of the material. We already know what is buckling. That will happen when we have an element that is tall and not so thick, and the material will have some kind of compression, and we will have like some kind of deflection. Snapping is when an object cannot handle tension and will break. Dissipate is the force that will spread out in an area, and the forces will be transferred from one element to another element. For example, a truss bridge, we will have an element that is made out of triangles like this. And if we apply a load in this point, that load is a vector, and that vector will be divided in different small vectors, and a force, for example, of 100 pounds will be transmitted in different ways to the different parts that form that connection where the load was applied. Well, the forces will be transferred. The same happens when you have a beam that transfers the force horizontally to the piers. There are many types of bridges. Basic types are like a beam bridge, that is just a beam of several beams connected together, an arch bridge, suspension bridge, and it's a very important factor to understand the type of bridge that we will have, because it depends of the size of the obstacle. Well, if the span is very big, we can use some type of bridges. When the span is very small, we can use other bridge. Well, the biggest difference between the three bridges is the distance they can cross in a single span. Well, a beam bridge will not be able to cross the same distance with the same efficiency that an arch bridge, and even less than a suspension bridge. Well, let's look at the types of bridges. A beam bridge is a simple, you have a horizontal beam that is supported at each end by piers. You can have several beams connected together, and the further apart is the piers, the weaker will the beam become. Well, this type of bridges rarely span more than 250 feet. However, we can have bridges that are beam bridges that are tubular, like with a hole in the middle. Imagine that we have, for example, a bridge that is made of a piece of concrete that is thick, but has a hole in the middle. Well, this material will have vehicles, for example, and people will pass here in the top of the bridge. Well, this type of bridges will be able to support a very long span. But in general, when you have a beam, the bridge is not able to support that much span. Remember that if we do a bridge, the bridge will work like a beam in this type of bridges. Well, it will be convenient that is, if we make a section here that is made by elements that are more vertical and thick. Therefore, we can have another element there to have the thickness that we need. Okay, but we want always the pieces to be like that. A piece that is smaller in the thickness than in the height, like a beam. Well, it's not convenient to have a bridge with this form. With people here, it's better to have a bridge with this form, with the people here in the top. And if we need more space, because cars will happen, well, we can have two beams and connect them in some way to can have the thickness that we need. But this distance is very important. How tall the building is very important. Another type of bridge, when you have this kind of bridges, you know that you will have compression and tension. Compression in the superior part and tension in the inferior part. I already spoke about the fact that we can have a beam, and if we have two lines in this beam with some separation, same separation, when the bridge deform, this kind of separation will become bigger in the bottom, okay, because you have here some kind of extension of the elements, and here, for the contrary, it will become smaller. and that make what is the compression here in the superior part and tension. If the beam, for the contrary, is a beam where you hang the weights there, like this, well, the beam will tend to do like this, and you will have tension in the superior part and compression in the inferior part. Here became longer, here became shorter. Instead, in this side, we can look the superior drawing, we can look here in yellow, that will become shorter, and in brown, that will become longer. That is effect of compression and tension. Second, truss bridges. Well, we have every bar in this cantilever build that will be pushing or pulling force. I mean, every bar will be in tension or compression, and it will allow to bring all the forces together to the piers. Truss bridges work very well because you don't need so much material to do it. Why? Because the triangle is a very efficient, well, the truss became very efficient. You have more material where you need it. Arc bridges, for example, are not that efficient. You need much more material to do it. But it has a great natural strength, are easy to build. And thousands of years ago, people like Romans built arches out of stone. Most arches now are made out of steel or concrete. They can span until 800 feet. In arc bridges, what we'll have is that we'll have forces. Forces that will be squeezing the element and will in some way allow the bridge to support. If we have a force, let me go back in the superior area, the top here, that force will tend to move like this, and because the walls are there, it will return back and create this pushing, and because this side tend to push over there to the outside, in the central area, we will have a pushing force like this. And that will be able to support all the weights. Remember, for every force to the left, we need a force to the right. For every movement going up, we need a movement going down in order to have an equilibrium of forces. Suspension bridges are the ones that we have sometimes like trusses in the roadway that are supported by cables. Well, the idea of the suspension bridge is that you have, for example, a pier and another pier, and you will have here the deck, and to support the deck, you have a cable, and from the cable, you have a secondary cables that are hanging. I mean, there is not a cable that goes directly from the pink deck to the pier, but there are two types of cables. The one in this arch and the ones that go directly that are suspended from that arch. That's why it's called suspension bridge. A different type of bridge will be a cable stay bridge. In here, in this type of bridge, let's use the same color, you will have two piers in yellow, for example, and you will have a deck in pink, and after you will have cables that will go directly from the pier to the bridge. And this is the next type of bridge. It's different because they go directly, they connect directly, that is the cable stay. Well, we can look here in the suspension that we have the tension element that are cables and suspension elements that are the other cables, also in blue color, and after the tower will be in compression. The cable stay, instead, you have the direct connection, as I told you. You have tension cables that go directly from the bridge to the pier, and you can have them together. Those kind of bridges can have a span from 500 to 3,000 feet. Usually they work very well for long span, but the bridges that have a longer span usually are the suspension bridges. There is an interactive page here that you can try to understand a little bit all the forces that affect a structure. And all this is related, obviously, with very simple theories of the Pythagorean theorem that tell us what is the relationship between the different elements and how the forces will work, and after everything that we studied before, how a force will be supported by two reactions, and the summatory of moments in one place will allow us to understand how much are the different reactions. Also, there is some math related with mechanics of materials, and one of the elements that is necessary to calculate is the model of elasticity that we will study later on. We already know what is stress and what is strain. Well, the modulus of elasticity is the stress divided by the strain. Stress is force divided by area, and the strain is the change of longitude of an element divided by the original length. Well, that will allow us to understand how the bridge works. Well, there are some basic maths and science elements that are necessary to understand, and you can read this information that we already spoke about it. And if we speak about basswood information, for example, because we will do later on a bridge in balsa wood, like a truss, you can look the different type of strain and tensile strength that this material can have. When we speak about bridges, we will need to do a truss analysis. This truss analysis is not part of today's class, but there is a formula that we will study later on that will tell us if the number of members in a truss is adequate or not. If we have more members, we cannot solve the equation and understand how a truss works. If we have less members than necessary, then the truss is not stable. In few words, what we want to do when we design a truss bridge is that we depart always for a triangle, and for every two new members, we have one new joint. 2 members, 1 joint. 2 members, 1 joint. Like starting for 3 elements and 3 joints, we want to arrive always to this type of design. It can be in the way that you want, but you are doing this always in the same way. When we have 1 member and no new joints, then this member is a member that we probably do not need. But this type of formula and calculation will be evaluated later on when we study trusses. Well, we can look here at the truss analysis with the number of joints and samples. And in this case, for example, we have a stable truss because for every joint, we have the number of members that we need. We depart with 3 joints, 3 members, and it works. Well, it's possible to just understand what kind of force each one of these elements has. And there is here for future analysis, bridge software that will allow you to understand the loads that each one of the bridges are supporting. Well, for the next projects, you need to draw your preliminary design. You will do all the joints, and you will glue all the elements without any gap filler and make the structure preferable to be symmetrical in order to make it to work well. It's very important to understand that the connection is the most important point when you build a bridge. And interconnection is the place where the bridge can be break. I would like to speak about 2 bridges that collapse. Unfortunately, one is the Florida International University Bridge in Miami that collapsed in 2018. This was a bridge that was pre-made and put in place very fast. The thing is that the different pieces of the bridge obviously will need to be connected, and that was one of the problems that happens. Well, the bridge was transported by some equipment and put in place, and it was necessary to locate this bridge in the top of the base that was already built. The idea was to don't interrupt so much the traffic there. The bridge was made out of concrete, and it was supporting a lot of axial forces in those particular areas. Well, they need to remove an anchor wedge in order to stress the element. There are elements made out of concrete that can be post-tense. I mean, the steel inside will be stressed later on in order to allow this to work. But in the first diagonal, they have a failure, and that produces bending in the slab deck and a plastic hanging in the canopy of this element. And unfortunately, the post-tension anchor was not adjusted in the way that need to be. That is something that is not easy. And the tendon was stretched or tension to remove the wedge, and the elongation result in an additional tension that break the element, and unfortunately the bridge was unable to support the weights. Another one is the Tacoma Narrow failure. I would like you guys to research about this particular bridge and understand how the members in a truss are in tension and which are in compression, and therefore understand that when we have a cable stayed bridge, the wind can produce movements and really be very negative for this particular element. You will have in our module information about this bridge through a film that will explain just the moment when the bridge collapses. This will conclude this presentation. Thank you very much.